Intensity of electric field at any point on the equatorial line of the dipole. Now we are going to derive a formula for the intensity of the electric field at any point on the equatorial line of the dipole. For that, we are considering a dipole consisting of charges minus q and plus q separated by a distance 2a. Okay. Let O be the midpoint of the dipole. Let O be the midpoint of the dipole. Then this line Mn, this line Mn represents the equatorial line. Equatorial line is the line passing through the center and perpendicular to the length of the dipole. Let the position of these charges can be represented as A and B. A and B. Now, consider a point P. P is a point at a distance y from the center of the dipole. Therefore, our question is, what is the intensity of the electric field? What is the value of the intensity of the electric field at P due to the entire dipole? We can assume, let it be E. E be the intensity of electric field at P due to the dipole. Then, how to find out the intensity of the electric field at P due to the entire dipole? For that, we can use Coulomb's law and the principle of superposition. First, we are finding out the intensity of the electric field at P due to the plus q along. Then you find out the intensity of the electric field at P due to minus q. After that, you can add both these fields, then you will get the value of E. Therefore, we can assume intensity of the electric field at P due to plus q along is equal to E1. Okay. The intensity of the electric field at P at the point P means, it is the force acting on 1 coulomb of positive charge placed at P. To find out this value, you can connect this line. Okay. Therefore, the distance between plus q and P is given by Bp and it is equal to R. Then, what is the direction of the intensity of the electric field at P due to plus q? It is directed along this direction. E1 is directed along this direction. This is the direction. Okay. It is directed along Bp. It is directed along Bp. This 1 coulomb of positive charge is repelled by plus q. Okay. Then, the intensity of the electric field at P due to minus q is equal to E2. To find out E2, you can connect this line. It will be P. Then, this 1 coulomb of charge will be attracted by minus q. Therefore, the direction of E2 is very clear. It is along P. Therefore, it is directed along PA. Okay. Now, what is the total intensity here? What is the total field due to plus q and minus q? That is E is equal to E1 plus E2. Because E1 and E2 are the vectors, you have to add it vectorically. Before adding, you can find out the magnitudes of E1 and E2. What is the magnitude of E1 and E2? The magnitude of E1 is equal to 1 by 4 pi epsilon 0 into q by the distance square, that is r square. Then, what is the magnitude of the intensity of the electric field at P due to minus q? It is also given by 1 by 4 pi epsilon 0 into q by this distance square. You can see here, from the geometry of the diagram, PA is also equal to BP. Because it is an isosceles triangle. The point is on the equatorial line. The point is at a distance y from the center of the dipole. Therefore, both the distance will be equal. Therefore, it will be R only. Therefore, the magnitude of E2 is equal to 1 by 4 pi epsilon 0 into Q by R square. Now you understood the magnitude of E1 is equal to the magnitude of E2, but the directions are different. E1 is directed along BP and E2 is directed along P. Then to add these two vectors, we can draw a line parallel to the axial line. Why you are drawing a line here? To add E1 and E2, we are drawing a line parallel to the axial line of the dipole. Let it be x dash. Okay. Now, what is this angle? This angle, let it be theta. Therefore, angle PAO is equal to theta. Angle PAO is equal to theta. Then what about this angle will also be theta. Then, once this angle is theta, this angle will also be theta. Therefore, because this line is making an angle theta with the axial line, this is a parallel line, therefore this angle will also be theta. Now, you can resolve E1 into two mutually perpendicular components. You have studied how to resolve a vector into two mutually perpendicular components in class 11. You can see here, if R is the vector and theta is the angle, then this vector can be resolved into two mutually perpendicular components along the x-axis and also along the y-axis. This is called adjacent component. It is given by R cos theta and this is given by R sin theta. Therefore, this technique we can use here. Then what about this value? E1 can be resolved into two mutually perpendicular components. This is the adjacent component. Therefore, it is E1 cos theta. And this is E1 sin theta. Therefore, this component is E1 sin theta and this component is E1 cos theta. Therefore, we have resolved E1 into two mutually perpendicular components. Why you are resolving this E1 into two mutually perpendicular components? For adding E1 and E2. Now, you can come to E2. Because this angle is theta, this is an alternate opposite angle, this also will be theta. Therefore, now you are in a position to resolve E2 into two mutually perpendicular directions in these two directions. Once you resolve E2, this adjacent component, it will be E2 cos theta. Therefore, E2 can be resolved into two components. One is E2 cos theta and this component is E2 sin theta. Therefore, now we have resolved E1 and E2 into two mutually perpendicular components. We have already shown that magnitudes of E1 and E2 are equal. Therefore, what happens? E1 sin theta and E2 sin theta will be equal and they are in the opposite directions. Therefore, from the figure it is very clear the perpendicular components cancels. Therefore, once you add E1 cos sin theta and E2 sin theta, you will get zero value. Therefore, the perpendicular components are cancelling each other. Then what is the total value? Then the total value is the sum of E1 cos theta and E2 cos theta. From here you can see that both the components are in the same direction. Therefore, it is easy to add, or it is the simple sum of E1 cos theta and E2 cos theta. Okay. Therefore, what is the value of E? E is equal to E1 plus E2. Here we understood E is equal to E1 cos theta plus E2 cos theta. Why? Because E1 sin theta and E2 sin theta. These are the perpendicular components. E1 sin theta and E2 sin theta are equal. They are cancelling each other. Therefore, E1 cos theta and E2 cos theta are the components remaining. They are in the same direction. Therefore, the total is given by E is equal to E1 cos theta plus E2 cos theta. You can substitute the values of E1, magnitudes of E1 and E2. E1 is 1 by 4 pi epsilon 0 into Q by R square cos theta plus 1 by 4 pi epsilon 0 into Q by R square cos theta. Therefore, what is the total? It is a simple sum that is equal to 1 by 4 pi epsilon 0 into 2Q cos theta by R square. 2Q cos theta by R square. Okay. This is the formula for the intensity of the electric field at a P due to the entire dipole. Now, from triangle APO, you can see the triangle APO. APO, this triangle. From APO, you can take the value of cos theta. Cos theta is equal to adjacent side by the hypotenuse. Therefore, it is A by R. A by R. Therefore, the equation becomes E is equal to 1 by 4 pi epsilon 0 into 2Q by R square into A by R. Therefore, E is equal to 1 by 4 pi epsilon 0 into 2Q into A divided by R cube. 2Q A divided by R cube. You can rewrite this term just like here, just like this. E is equal to 1 by 4 pi epsilon 0 into Q into 2A divided by R cube. Q into 2A divided by R cube. Here we know Q into 2A is called P, the dipole moment. The dipole moment of the dipole. Therefore, you can substitute P instead of Q into 2A. Therefore, you are getting the formula E is equal to 1 by 4 pi epsilon 0 into P by R cube. Okay. Let us discuss the point once again, because the intensity of the electric field at P due to the entire dipole is given by E1 plus E2. E1 is the intensity of the electric field at P due to the plus Q, and E2 is the intensity of the electric field at P due to minus Q. These are in these two directions. To add E1 and E2, we have resolved E1 and E2 in two mutually perpendicular directions. E1 is resolved into E1 cos theta and E1 sin theta. E2 is resolved into E2 cos theta and E2 sin theta. The magnitudes of E1 and E2 are equal. Therefore, the perpendicular components cancels each other. Then the total is the sum of the parallel components, that is E1 cos theta plus E2 cos theta. Once you substitute the values, we are getting, after simplification, we are getting E is equal to 1 by 4 pi epsilon 0 into P by R cube. Then here we got the value E is equal to 1 by 4 pi epsilon 0 into P by R cube. Okay. Then from triangle, again you can take the triangle APO. From triangle APO, you can apply Pythagoras theorem. We are getting the value as R square is equal to A square plus Y square, or Y square plus A square. You can take the square root here. Therefore, R is equal to Y square plus A square, the whole raised to 1 by 2. Then what is the value of R cube? Take the cube root. R cube is equal to Y square plus A square, the whole raised to 3 by 2. You can substitute the value here. Therefore, you are getting E is equal to 1 by 4 pi epsilon 0 into P by Y square plus A square, the whole raised to 3 by 2. This is the formula for the intensity of the electric field at any point on the equatorial line of the dipole. But you see here, the intensity of the electric field at P due to the dipole is directed along this direction. This is the direction. E1 plus cos theta gives in this direction. But the direction of P, you know, it is directed from minus Q to plus Q. Therefore, this formula needs a correction. That is why for correcting that point, we are putting the negative sign here. Therefore, E is equal to minus 1 by 4 pi epsilon 0 into P by y square plus a square the whole raised to 3 by 2. What does it mean? The intensity of the electric field at any point on the equatorial line of the dipole is directed opposite to the direction of the dipole moment. Okay. Usually for a dipole, y is very, very greater than a. We know the distance between the charges may be very small. Therefore, y is very, very greater than a. Therefore, a square can be neglected. Or the value of a square is 0. Therefore, the formula of E becomes E is equal to minus 1 by 4 pi epsilon 0 into P by a square is 0. Then once you simplify, you will get P by y cube. This is the formula for the intensity of the electric field at any point on the equatorial line of the dipole. E is equal to minus 1 by 4 pi epsilon 0 into P by y cube. P is the dipole moment. Y is the distance between the center and the point. Okay. Again, we can remember the formula for the intensity of the electric field due to the dipole in these two directions. This is minus q and plus q. O is the midpoint. The distance is 2a. This is the axial line of the dipole. We know this is the axial line of the dipole, and this is the equatorial line of the dipole. Equatorial line of the dipole. Here, P is a point. P is the point at a distance x from the center of the dipole. R is a point at a distance y from the dipole. We have the formula. The intensity of the electric field at P is equal to 1 by 4 pi epsilon 0 into 2p by x cube. We have studied. Then the intensity of the electric field at R is given by Ey equal to 1 by 4 pi epsilon 0 into p by y cube. Here it is 2p, here it is p. Okay. Therefore, we have studied the formula for the intensity of the electric field at any point on the axial line and also on the equatorial line. Here negative sign is here. What is the meaning of this negative sign? The negative sign shows that the intensity of the electric field at any point on the equatorial line is opposite to the dipole moment, opposite to the direction of the dipole moment. The intensity of the electric field at any point on the axial line is in the direction of the dipole moment. Therefore, these two directions are opposite. That is the meaning of the negative sign here. Okay. Then, if x is equal to y and that is equal to, suppose it is equal to k, then what will happen? Means you are considering 2 points equidistant point from the center of the dipole. That means you are having 2 points at equal distances from the equal distance on the axial line and also on the equatorial line. Then what will be the intensity of the electric field at this point? Axial line, it will be 1 by 4 pi epsilon 0 into 2p by k cube. Here it is. Intensity of the electric field on the equatorial line will be given by minus 1 by 4 pi epsilon 0 into p by k cube. From this you can understand that Ex is equal to minus 2Ey. Means the intensity of the electric field at any point on the axial line is twice the intensity of the electric field at a point at a corresponding point on the equatorial line. Okay. The intensity of the electric field at any point on the axial line is twice the field at a corresponding point on the equatorial line, but the directions will be opposite. This completes the discussion of the intensity of the electric field due to a dipole in 2 directions axial line and equatorial line. Thank you.